Hello everyone, I'll be presenting you the solutions of part test 17. So let's start with the first question. The SI unit of 1 by 2 pi root LC is equivalent to that of, we know that omega is equal to 1 by root LC is angular frequency of LC oscillations. So directly the answer will be B, which is frequency. Next question, the radius of the sphere is 5.3 plus minus 0.1 centimeter. The percentage error in the volume will be, so the volume is given by 4 by 3 pi r cube. So delta V by V, which is the relative change in volume, into 100, which is the percentage change in volume, will be 3 delta R by R into 100, which is 3 into 0.1 by 5.3 into 100. Next question, x is equal to at plus bt square plus c. So every term should have same dimension because same dimensions only can be added. So everything should be meter. So c is simply meter. B into time square will give the dimension of length. So B is LT minus 2, which is meter per R minus 2. A is AT is equal to L. So A is LT minus 1, which is meter per hour. This is the correct answer. Next question, a small telescope has objective lens of focal length 140 cm and eyepiece of focal length 5 cm. The magnifying power of telescope when the final image is formed at least distance of distinct vision. So in this case, focal length is given by minus FO by FE into 1 plus FE by D. We simply put the values 140 by 5 into 1 plus 5 by 25. When we solve it, you will get 25 into 1.2, which is almost equal to 34 centimeter. Next question, Fraunhofer diffraction single slit of which the wavelength of the light is given. The first minimum is observed at 30 degree. So we know that condition for minima in single slit diffraction pattern is d sin theta is equal to n lambda, where n starts from 1, 2, 3, 4, and condition for maxima is d sin theta is equal to 2n plus 1 lambda by 2, where n starts from 1, 2, 3, 4. So from minima condition, d sin 30 is the first minimum, which means only lambda, implies that when we put the value, we get d is equal to 2 lambda. This is our first equation. Now the question is for secondary maximum. For secondary maximum, d sin theta will be equal to 3 lambda by 2. We put n is equal to 1. So from here, d is equal to sin theta is equal to 3 lambda by 4d, and d value is 2 lambda. So you will get, it is 2. So you will get 3 lambda by 2 into 2 lambda, which is 3 by 4, implies that theta is equal to sine inverse of 3 by 4. Coming to the next question, propagation of light through optical fiber is due to total internal reflection taking place at core clad interface, which is true. The refractive index of material of core of optical fiber is greater than that of air. It is true, but it does not explain. So the core should have more refractive index than the cladding, and it is saying greater than that of air, which is true, but it does not explain anything about DIR. So option is B. If it was cladding here, then it would be A. Next question. The question was slightly changed. So I was given to be 30 degree and the options were changed. So I'll just cut it here. So the rays incident at 30 degree, angle of prism is given, deviation is given, angle of emergence is asked. So we know simple equation del is equal to I plus E minus A. So it is given to be 55 is equal to 30 plus E minus 60. When we solve it, we get E is equal to 85 degree. Next question, mass number A of nucleus is related to surface area X, as we know that radius of a nucleus is proportional to A to the power 1 by 3. So surface area is proportional to R square is proportional to A to the power 2 by 3. Next, in nuclear fission, 0.15% of mass is converted into energy. So energy of fission of 3 kg masses. So E is equal to mc square. By using mass energy equivalence, we will get 0.15 by 100, which is 0.15% into 3 into c square, which is 9 into 10 to the power 16, and we'll get the answer in joule. To match the correct option, let's convert this into electron volt. So what we'll do is, we'll divide this answer by 1.6 into 10 to the power minus 19 electron volt. And when you solve it, you will get nearly 2.6 into 10 to the power 33 electron volt. Which is this. Approximately you can solve it very easily. So just take it 0.1, slightly less than 0.1. And this is 9 3s are 27, so roughly you will get 2.6, and 2.53 is actually the accurate answer. Next, energy band diagram for 3 semiconductor samples of silicon are given. So here, the Fermi level is here. The highest occupied electrons are here, which means it is undoped. In this, the Fermi level is this, highest occupied electrons have shifted upwards, which means they are just below the conduction band, which is for the case of n-type. And here the acceptor level is just above the donor level. This is for p-type. I'm sorry, here the Fermi level will be just in the middle. So this is n-type, this is p-type. N-type means the fifth group. So Y should be fifth group, which is the correct option. X is undoped. Yes, this is the correct option. N-type, this is p-type. Coming to the next question, Zener diode having breakdown voltage 15 volt is used as voltage regulator. The current through the diode is. So it's being operated under breakdown voltage. So voltage across this is 15 volt. So in this branch also the voltage will be 15 volt. So V is equal to IR. So the current through this will be I is equal to V by R is equal to 15 by 1000. is equal to 15 milliampere. So 15 milliampere is flowing in this direction. Let's assume 0 volt here, so it will be 15 volt here and 20 volt here. So the current flowing through this resistance I will be 20 minus 15 by 250 is equal to into 4 upon 4. If we do, we'll get 20 milliampere, and this current will be divided into two segments, and here the current is 15 milliampere, which means the current here is 5 milliampere. Next question, we have to mark the truth table. So this is A. If we look carefully, this is A bar, this is B, this is A, this is B bar. Here you will get A bar plus B whole bar, because this is a NOR gate. Here you will get A plus B bar whole bar. This is also a NOR gate. So Y will be A bar plus B whole bar dot A plus B bar whole bar, which is an AND gate. If we apply De Morgan's law, we will get A B bar into A bar B. A into A bar is 0, B into B bar is 0. The answer is always 0. So the always 0 means C. Next, in YDSC experiment intensity on the screen, where the part difference is lambda is K. So part difference lambda means maximum intensity, which is 4I0, and this is given to be K. Intensity at a point where part difference is lambda by 2. So at that point, what is the phase difference? 2 pi by lambda into delta x. 2 pi by lambda, delta x is lambda by 4, which is pi by 2. So the phase difference at that point is pi by 2. Intensity at any point is given by I is equal to 4I0 cos square phi by 2. 4I0 is given to be K. So the answer will be K times cos square. Phi by 2 will be pi by 4. Cos pi by 4 is 1 by root 2, whose square is 1 by 2. So the answer will be K by 2. Next question, SI unit of electric flux. So electric flux phi has the dimensions of electric field into area. Area has dimensions of area is length into length. Electric field into length has the dimension of potential, which is volt, into length, implies that unit is voltmeter. This comes from E dot dl formula. This comes from integration E dot ds formula. Next question, relation between polarizing angle and critical angle is. So the polarizing angle, also known as Brewster's angle, the formula is tan IB is equal to mu, and critical angle tan IC is given by 1 by mu. For air and any medium, we can write mu2 by mu1 and mu1 by mu2 here. So basically IB will be tan inverse mu, and mu can be written as 1 by sin IC, which is cosec IC. A. Next question, coherent sources intensity I1, I2 produce an interference pattern. Maximum intensity in the interference pattern. So we know that for maximum intensity, amplitudes are added. Amplitudes get added. And amplitude is proportional to root of intensity. So we'll get root of intensity 1 plus root of intensity 2, which is proportional to net amplitude, and if we do it whole square, we'll again get the intensity. So this is I max. We can also do it using trial and error. if so this has this and this is directly wrong because it is dimensionally incorrect, and intensities do not get added, amplitudes get added, so obviously this should be the correct answer. Next, small object is enclosed in a transparent solid sphere of radius 8 centimeter. So this is 8 centimeter. Object is situated 2 centimeter from the center. This is object position. Image appears at 3.2. So this is 3.2. This is 6. This is the interface. So we will use the formula for refraction at a spherical surface, which is mu2 by mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Mu2 is final medium here, which is 1. We take this side as negative, this side as positive. So you will get 1 by minus 3.2 minus mu by, this is mu, which is mu1, and outside is air, mu by minus 6, u is also minus 6, is equal to mu2 minus mu1, which is 1 minus mu by minus 8. So let's shuffle it. You will get mu by 6 plus 1 minus mu by 8 is equal to 1 by 3.2. So 24 is the LCM. We will get 4 mu plus 3 minus 3 mu is equal to 1 by 3.2. So implies that mu plus 3 is equal to 24 by 3.2, which is 7.5. Implies that mu is equal to 4.5. I believe the options were changed. So option is 4.5. Next, identify the correct operation performed by the circuit below. So this is A, this is A, this is A plus A bar, which means A bar. So similarly B bar, and this is C bar. So this is A plus B plus C, A bar plus B bar plus C bar whole bar, which is simply ABC, which is AND gate. Next question. MP denotes the mass of proton and is the mass of neutron. Mass of the nucleus is given by. So we know that binding energy of a nucleus is equal to number of neutrons into mass of neutrons plus number of protons into mass of protons minus the mass of nucleus into c square. This is the binding energy. If we shuffle it, we will get B by c square is equal to NMN plus ZMP minus M. So if we shuffle it, we will get our answer as C. Obviously these are wrong. B into c square does not even have the correct dimensions. Next question. For mass defect of 0.3%, the binding energy of 1 kg material is. So mass defect is related to binding energy by this relation. So mass defect is 0.3%. So 0.3% of 1 kg into c square is 9 into 10 to the power 16. When we solve it, you will get 2.7 into 10 to the power 14 joule. Next question. Light of wavelength this much is incident on a slit of width this. Find the width of central bright line on the screen. So this is basically a question of Fraunhofer diffraction. So width of the slit pattern is given by 2 lambda capital D by small d, which is 2 into 5000 into 10 to the power minus 10 into capital D 2 by small d is 0.1 into 10 to the power minus 3. When we solve it, we will get 20 into 10 to the power minus 3 meter, which is 20 mm. Next question. In the following circuit, the equivalent resistance between A and B is. So this is minus 10 volt. This is minus 2 volt. So this is at higher potential. This is at lower potential. So basically these two diodes will act like a open circuit because they are reverse biased. So the current will directly flow in this path. So the total resistance is 6, 7, 8 plus 8, 16 ohm. Next question. Focal length 10 centimeter equi-convex lens is given. It is cut and separated and the refractive index 3 material is filled between them. So we'll just calculate the focal length of this part. To calculate this focal length is simply what? 1 by f is equal to mu minus 1 by r1 minus 1 by r2 is equal to 3 minus 1 by r1 is and this is plus 1 by 10. How did we calculate r1 and r2? To calculate r1, we apply the same formula in the actual lens. What is the radius of curvature of this lens? 1 by f, which is the focal length, plus 10. So 1 by 10 is equal to 3 by 2 minus 1. 3 by 2 minus 1 is 1 by 2. 1 by r1 plus minus 1 by r. So you will get 1 by r plus 1 by r, 2 by r, and the r gets cancelled. So you get the radius of curvature also as 10 centimeter. So this is a special case which we can remember. If mu is given to be 3 by 2 and it is equiconvex, so the focal length and the radius of curvature of the lens will be same. So yes, basically from this we put radius of curvature here because the radius of curvature of the lens and the material which we fill will become same. So when you put the answer, we get f. Consider it f dash. So f dash is equal to minus 10 by 4 is the focal length of this lens. So now we have basically our old lens. So if we flip the lens and again attach it, we get the same lens again. So this lens is same as this lens, but it has extra material here which also acts as a lens. So the powers of the lens will be added. So 1 by f effective will be 1 by f1 plus 1 by f2. Implies that 1 by 10 minus 4 by 10, which is minus 3 by 10, implies that f effective is equal to minus 10 by 3. So implies that p value is given to be 10. Next question. Atomic nucleus 92 emits these series of alpha and beta particles what is the z of resulting nucleus. So if we carefully count, there are 8 alpha decays, and in each alpha decay z changes by -2. There are 4 beta minus decays. In each beta decay changes by +1, and there are 2 beta plus decays. In each decay it changes by -1. So what do we get? -16 from here, +4 from here, -2 from here. So what we get total as -14. So total -14, which is 92 minus 14, is equal to 78, is our final answer. The density of the material in CGS unit is this. We have another set of units. What is the density of the material in that unit? So we will simply use N1 U1 is equal to N2 U2. So N1 unit is ml minus 3 for density. So we will write M1 L1 to the power minus 3 is equal to N2 M2 L2 to the power minus 3. N1 is 4 because we have 4 gram per centimeter cube. M1 is gram, L1 is centimeter, equal to N2, which we have to find. M2 is 100 gram and L2 is 10 centimeter. So we'll get 10 to the power minus 3 centimeter to the power minus 3. So all the units will get cancelled. We'll get 4 is equal to N2 into 1 by 10. So N2 is equal to 40. So that was it for this paper. Thank you.